have special forms, we're actually able to do some further factoring. Let's look at this one first. 9a cubed plus 27a squared minus 4a minus 12. Let's follow our factoring strategy. Is there a greatest common factor? No. So I look to see how many terms there are. There are 4 terms, so I have to do grouping. Okay, group the first 2, group the last 2. What do the first 2 have in common? They both have a 9, they both have an a squared, so I'll pull that out. What do the second 2 have in common? They both have a 4, but I'll pull out negative 4 because I have a leading negative on that second pair. Always pull out a leading negative. If I pull out 9a squared from the first term, I'm just left with a plus 3. Pull out negative 4 from the second set, and I'm left with a plus 3. So that looks good. Do a quick double check in your mind. 9a squared times a, yes, that's 9a cubed. 9a squared times 3, yes, that's 27a squared. Negative 4 times a, yes, that's negative 4a. Negative 4 times 3, yes, that's negative 12. Now I know my grouping worked because my binomials match. The stuff in the parentheses is the same. Don't keep going if those don't match. So I pull that common a plus 3 out front and write 9a squared minus 4. Now, the next thing in my factoring strategy says to look for further factoring. This is where I stopped before I thought I was done. But let's look at this a little bit. I have a plus 3 and then the 9a squared minus 4. If you look at the 9a squared minus 4, do you see the difference of squares? Right there. So that's 3a squared minus 2 squared. So that's 3a plus 2, 3a minus 2. So my final factoring is a plus 3 times 3a plus 2 times 3a minus 2. So these special forms allow me to factor things that I never would have been able to factor before. Okay, we would check it by just multiplying things back through just to mix it up. I'll multiply them in a different order. Combine my like terms, FOIL it again, find my like terms, and I get exactly what I started with. Okay, let's do another one. Okay, so now that you pause this and do this on your own. Okay, is there a greatest common factor? No. How many terms are there? There's 4, so we'll group. Group the first pair and group the second pair. The first pair, what do they have? They have a w squared. The second pair has a 4, but it's got a leading negative, so I'm factoring out a negative 4. If I pull w squared out of w cubed, I'm left with w. If I pull w squared out of negative 2w squared, I'm left with negative 2. Okay, if I pull negative 4 out of negative 4w, I'm left with w. If I pull negative 4 out of positive 8, I'm left with negative 2. If that's confusing, go make sure you do a quick double check. W squared times w is w cubed. W squared times negative 2 is negative 2w squared. Negative 4 times w is negative 4w. And negative 4 times negative 2 is positive 8, so that does work. Pull out my common w minus 2. Now, am I done? Look for further factoring. No, I've got a difference of squares. So, right there, that's w squared minus 2 squared, so it's w plus 2, w minus 2. And if we look, we actually could write that a little bit more simply. We could write that as w minus 2 squared times w plus 2. If you want to leave it as the line above, that's fine, but it's a little simpler down below. So to check, okay, so that we know that this factors this way, let's check our work. Now remember, w minus 2 squared is not w squared minus 2 squared. We have to write it out so that we have w minus 2 times w minus 2 times w plus 2. FOIL out the first pair and we'll get w squared minus 4w plus 4, and then we'll distribute that through to the w plus 2. Cancel everything that we can, combine where we can, and we're right back where we want to be. It does check.